Let's look at another example of how we use dimensional analysis. How many pounds is 652 grams? And we're given the relationship that 1 pound equals 454 grams. We first need to determine our starting units and our units for our answer. And so we see that we're given 652 grams, so we know this is where we're going to start. This is our simple unit, just grams, not a relationship that we see between pounds and grams. And for our answer, we want our answer in pounds because it asks how many pounds. We set up our problem starting with 652 grams, which is given, and we know we want to get rid of grams, so it's going to go in the denominator of the next step, so 454 grams from our relationship that was given. On top, we're going to put 1 pound. Next, we're going to see what units will cancel, and we see that grams will cancel, and we're left with units of pounds. And when we do the math, we get 1.4361 ... continuing on our calculator, pounds. And so now we need to determine the number of sig figs in our answer. So we look back at the measurements in the problem, and we see that 652 has 3 sig figs, and 454 grams also has 3 sig figs. While the 1 is an exact number, the 454 is rounded, and so we do need to consider that in determining sig figs for our answer. As a result, we need 3 sig figs in our answer, so the first digit we're dropping is the 6. Because that's a number greater than 5, we're going to round to 1.44 pounds. Let's look at another example. A premature baby was born with a weight of 3 pounds 5 ounces. What was their mass in grams? And again, we're given the relationship 1 pound equals 454 grams. This problem is going to be a little bit different because we have to look at the fact that we have 3 pounds and 5 ounces. We have to combine that into the same unit. An important thing to note is that 3 pounds 5 ounces is not equal to 3.5 pounds. We have to actually figure out how many pounds is represented by 5 ounces before we can continue with this problem. So the first thing we're going to look at is 5 ounces, and we know that ounces is in the numerator, so we need ounces in the denominator, and 16 ounces is equal to 1 pound, so our ounces will cancel, and we're left with 0.3125 pounds. Notice that's very different than saying 0.5 pounds. Now we need to add the pounds together, so we get 3.3125 pounds for the weight of the baby. And we want pounds on the bottom because we want to cancel that unit out and get to grams. And we put our 454 grams on top. We're going to cancel out units of pounds. And now we can solve the problem, and we get 1.5 times 10 to the third grams. This problem also could have been solved by taking the 3 pounds and converting it to ounces, and then converting the total number of ounces to pounds and then to grams. Either way would give you the same answer. Let's look at an example that has a different kind of relationship given in the problem. An aluminum sphere has a volume of 3.65 centimeters cubed. What is the mass given its density is 2.70 grams per centimeters cubed? This relationship is true for aluminum, but would not be true for another substance. Unlike some relationships, say for example 1 pound is 16 ounces, it doesn't matter what the substance is, that relationship is always true. In this case, the density is unique to the specific substance, so it has to be given in the problem. So let's look at the problem and figure out what our starting units are. It's giving us the value 3.65 centimeters cubed. We also have another number, but notice that centimeters cubed is a simple unit. It's 1 unit as opposed to a relationship like grams per centimeter cubed. So we're going to start with centimeters cubed, and it's asking for the mass. And so the most common unit of mass that we'll see is in grams. Mass can be given in other units such as kilograms or milligrams, but because we're given the density in grams per centimeters cubed, we're going to go to grams. Notice that this is a relationship that is specific to aluminum, and it's going to be different for different substances. So we start with our 3.65 centimeters cubed. We know that centimeters cubed needs to go on the bottom of the next step because we want to cancel those units out. And so we see that we have 1 centimeter cubed on the bottom, so 2.70 grams goes on the top, and that's from the relationship given in the problem. If it's a 1, you often see that it won't be written in the problem, and so we don't actually have to include it in our setup, but you can if you choose. Now we see that centimeters cubes cancel out, and now we can do the math and find we get 9.86 grams for our answer.